Hi, here we're going to look at a couple of reduction reactions. Reduction, if you remember from our mnemonic oil rig, is oxidation is loss of electrons or hydrogens, and reduction is gain of electrons, hydrogens, or a loss of oxygen. So we're looking at reduction half reactions. So when we have a reaction like this, the first thing we want to do is find the reactive functional group. In this case, I'm looking for double bonds. Usually it's going to be a double bond I'm looking for. I see a carbonyl at the end of a chain. I can tell it's at the end of the chain because of the hydrogen. And so this tells me that this is an aldehyde. Next, I look over the arrow to find out what kind of reaction this is going to be. And I see the H there, which tells me I'm going to be doing reduction where I gain hydrogens. Okay? Those hydrogens are going to add across the double bond, like we always see with double bonds. So hydrogen will have one add to this side of the double bond to the carbon. We'll have another one add to this side of the double bond to the oxygen. And that's going to give us this product. It is an alcohol. To draw that a different way, I can use skeletal structures, so let me show you what that looks like. You can see that down below, and I want to be careful that I'm counting my carbons well. So here's one carbon, here's two carbons to an aldehyde, and then in my product I still have two carbons. Here's one, here's two to an alcohol. Finally, the interesting thing about a reduction reaction is it's just simply the reverse of an oxidation reaction. So if I were to run this reaction in reverse, going this direction, it would be oxidation. Alright, next I'll show you an example of a ketone being reduced on the next page. So here's the reaction that we're given. Again, first of all, I want to find the reactive functional group, looking for double bonds, and here I have a ketone. Again, I'm looking for what type of reaction it's going to be, and I look over the arrow to get a clue for that. I see H, which means I have H's to add. In other words, I'm going to reduce. Reduction is gain of H's. H's will add across the double bond, so one to each side of that double bond, and here's my product. So I see that now I've added an H right here, I've added an H right here, and my product is a secondary alcohol. So a ketone can be reduced to form a secondary alcohol. If I draw this with skeletal structures, let's keep it pointing down here, so I take a ketone, add some reducing agent that can donate those H's, and my product looks like this. Again, this should look kind of familiar. If I run this reaction in the reverse direction, then I would see that it is oxidation. So reduction forward, oxidation backwards, they go together.